Hello friends, today we are going to learn about the domain of a composite function. How to find the domain of a composite function. So first we have to find the how to find the domain of how to find the composition of a function. Let's see one example. Here find the domain of a find the composition of a function g composite f of x. Here f of x is equal to x square is an one function and g of x is equal to square root of x is another function. F of x and g of x are two functions we have given, and we have to find g composite f of x, that is nothing but g of f of x. So replace f of x is the inner function and g is outer function, so replace f of x by x square, so you get g of x square, and the value of g of x is equal to under the square root of x. So here we have to find the g of x square. So replace x by x square. So square and square root both get cancelled. You get g composite f of x is equal to x. Here also you can find f composite of a g of x. Similarly, this is a very simple method. You can solve by the same procedure. Here few steps for finding the domain of a composite function. First, find the composition of a function, find the domain of a f, find the domain of a g. Find those input x in the domain of a f for which f of x is in the domain of a g. That is, exclude those inputs of x from the domain of a f for which f of x is not in the domain of a g. The resulting set is the domain of f, g composite f. So domain means the set of a point at which function is well defined. So we have to find the set of point at which function f, g and their composition is also well defined. So now we will see the one example how to find the domain of a composite function. Here is one example. Find the domain of a composite function f composite g of x. Here is first step is that find the domain of f of x. That means find the set of point at which f of x is defined. Here we can easily find out the function f of x and g of x is a rational function. So here we can easily find at which point function is undefined. So first find the set of point at which f of x and g of x are undefined and remove that point from the set of real numbers. So here we get f of x. So we will see that is nothing but here we will see one example. That is my previous task. So our function is f of x is equal to x upon x plus 3. Here function is undefined when denominator is equal to 0, because anything upon 0 is always undefined. We cannot define anything upon 0. So denominator is a 0. So x plus 3 is equal to 0. So we will get, subtracting 3 from both sides, so we get is equal to minus 3. This is nothing but x is equal to minus 3. So f of x is undefined when we plug a value of x is minus 3. That is, when we plug x is equal to minus 3, then our function is undefined, minus 3 upon 0. It is we cannot define the value of this. That's why at x is equal to minus 3, f of x is undefined. So remove the domain of f of x is the set of all real number except x is equal to minus 3. So exclude these points from the domain of f, that is x belongs to R such that x is not equal to minus 3. X belongs to R such that x is not equal to minus 3. This is the set of a real number. This is the domain. So similarly we can find the domain of a g of x where at plug x is equal to 0, at x is equal to 0 function is undefined. So the solution at x is equal to 0 function is undefined, at x is equal to minus 3 f of x is undefined, excluding the value of x for which g of x, we have to exclude these values of x for which g of x is equal to minus 3. So 1 upon x is equal to minus value of g of x is equal to 1 upon x, that is 1 upon x is equal to minus 3. 1 is equal, multiply both side by x, 1 is equal to minus 3x, divide both side by minus 3. We have isolate x on left side. Therefore the domain of your composite G is the set of real numbers except minus 1 upon 3 and 0. This means that x is not equal to minus 1 upon 3 and x is not equal to 0. We can write this in the interval notation as minus infinity to minus 1 upon 3 union minus 1 upon 3 to 0 union 0 to infinity. This is the domain of composite function of composite G. Here last is the conclusion. The domain of a composite function is the intersection of the domain of inside function, that is the domain of a g of x, and new function of composite g of x. The domain of the function is either same as the domain of the first function, either first function or lies inside f or g of x. The rational function's domain element must not create division by 0. And this is all about the domain of a composite function. I hope you will understood this video. Thank you.